Hello everyone, in this video we'll study about an public key cryptography which is an RSA algorithm. So in public key cryptographic model, a sender or receiver they use a pair of keys, that is they use the different keys. One is used for encryption and one more is used for the decryption. So this model it is also called as asymmetric or two key encryption. So in public key algorithm, it is based on the mathematical function rather than on a substitution or a permutation. So security of any encryption scheme indeed depends upon the length of the key and the computational work involved in breaking an encrypted message. Here we are going to study two kinds of public key encryption protocols. The first one is RSA algorithm and the second one is Diffie-Hellman key exchange algorithm. And in this video, we will just study about the RSA algorithm. So in the public key encryption method, either of the two related keys can be used for encryption and the other one is used for the decryption. So it is a asymmetric or a two key encryption. So here public key is mainly used for the encryption and the private key is used for decryption purpose. So two different keys are used for public key encryption protocols. So here we have the RSA algorithm. Here the Rivert, Shamir and Altman are the persons who invented this in 1978. So the RSA algorithm it is an asymmetric cryptography algorithm, and this means that it uses the public key and the private key. That is, two different keys are used in this algorithm. And as their name suggests, public keys it is shared publicly and everyone can have the access to that particular key, whereas the private key it is a secret key. That is, we can find the private key only with the receiver. It is a secret key and it should not be shared with anyone. It is kept secretly at the receiver side. The RSA algorithm it is named after the three persons who invented it in 1978. That is Rivert, Shamir and Altman. These three are the persons who invented this algorithm. So here we have the diagram which is going to show the asymmetric cryptography. So we have the sender as the receiver. Here we have the sender and at the other end we have the receiver. So the data that need to be sent from sender to the receiver. As we said, we are going to use two keys. The first one we can find it here and the other one we can find it at the receiver side. One is at the sender side and one more is at the receiver side. So whenever we are going to encrypt a message using the key, we call it as a ciphertext. So here we have the data that need to be sent and the sender encrypts the data with the receiver's public key. So receiver it has two kinds of key. First one is private key and one more is public key. Again sender has two kinds of key. One is public and one more is private. So what the sender does is, the sender has the public key of the receiver. So that kind of information is previously exchanged between the sender and receiver. Now the sender has the public key of the receiver. So what the sender does, they are going to encrypt the data, whatever they are going to send, using the sender's public key. So when you are going to encrypt it, it will be converted into a ciphertext and this ciphertext is transmitted across the network. Whenever the receiver receives that message is decrypted using the private key. So whenever you are encrypting the message with the receiver's public key, it can only be decrypted using the receiver's private key. Other keys are not possible to use. So when at the receiver side, whenever the message has been received at the receiver side, they are going to take it out and they are going to decrypt the data using the private key. So after decrypting it, they get back the original data which was sent by the sender. So this is how this RSA protocol works, with two different keys at the two different ends. One is at the sender and one more is at the receiver side. So here how this algorithm works, how to generate the keys, how the encryption and decryption is being done. So here RSA algorithm it has mainly three phases. The first one is key generation phase. As we are using two different kinds of keys, we need to generate those keys before transmitting the actual data. So the first one is key generation phase, second one is the encryption phase and the third one is decryption phase. So we'll just go with the first one right now, that is the key generation. So in key generation in an RSA scheme, the key length is usually it is of 512 bits, which requires an enormous computational power. So if you want to get an idea about the key that is being used for encryption or for the decryption, it is not easily available, so it requires the more computational power. So here the length of the key is usually 512 bits. A plain text is encrypted in blocks. It is a block cipher with each block having a binary value less than some number. So here block cipher is being used, so we are going to encrypt the data in terms of blocks. For each block we are going to perform the encryption as well as the decryption. So encryption and decryption are done as follows, beginning with the generation of public key as well as the private key. So here we'll begin with the key generation algorithm. How to generate the keys, public and private keys. So choose two roughly 256 prime numbers, A and B, where and we are going to derive n is equal to A into B. So here A and B are two different prime numbers which are of 256 bits. So prime numbers are the one which are divisible by 1 and its own number. That kind of numbers we call them as a prime number. So the numbers which are divisible by 1 and itself are usually considered as prime numbers. So we choose two roughly prime numbers which are of length 256 and we call them as A and B. So find x, that is select an encryption key x such that x and A-1 and B-1 are relatively prime. So here we have the definition of relatively prime. If they do not have a common factor which is greater than 1, then we call that kind of numbers as relatively prime numbers. So here we have we are going to find the value of x, which is a encryption, that is the public key of the receiver. We are going to find the public key of the receiver as, we are going to name it as x, and we are going to find that value using the previously chosen prime numbers, that is A and B. So x and A-1 and B-1, it will help to find the value of x. So after that we need to find the value of y, that is the public key, that is the private key at the receiver side. So how we are going to find the y? We already know the value of x, we already know the value of A, we already know the value of B, then it is easy to find the value of y. So from this equation we find the value of y, which is a private key of the receiver, xy mod A-1 B-1 is equal to 1. So at this point we are going to discard those A and B values. Then the public key is usually given as x comma n, where n is the message, and private key is y comma n, number of bits and the message. So here in this algorithm x and n are known to both sender as well as the receiver, where x is the private that is the public key, and n is also known to both the sender as well as the receiver. But the only thing that we don't know here is the private key, which is y. So y is the private key which is not shared with anyone and it has been kept as a secret thing. Also A and B must be large and about the same size and both greater than 1000, that is 1024 bits. So if the larger the values, then we call that as a secure algorithm. If we take the smaller algorithms, that is the smaller values, then it is easily, that is then if we have the hacker or intruder, then they can easily get the value of the key easily. So for this purpose we have to choose large prime numbers, so that for intruder it is difficult to hack it. So the second step here is encryption. Both sender and the receiver will know the value of n. The sender knows the value of x and only the receiver knows the value of y. So how we are going to perform the encryption? So we perform the encryption using the public key. Public key is given as x and the private key is given as y. So here cipher text, we are going to get the cipher text as message to the power x. X is the public key mod n. This is the formula that is being used to find the encryption method, that is to get the cipher text. So after that we are going to decrypt the cipher text to get back the original message. So cipher text to the power y, that is the that is the private key of the receiver, that is cipher text to the power y mod n, we get back the original message. So this is how the decryption is being performed at the receiver side. So here we have the example. In this we have the algorithm for an RSA algorithm. We have a 4-bit message. Those 4-bit messages 100100, or when this is the binary representation and we call the message as 9. we have chosen A is equal to 3 and B is equal to 11. Find the public and the private key for this security action and show the ciphertext. So here we have got the value of m is equal to 9, and we already have the values for A and B. We need to find the public and private keys and we need to show the ciphertext. So here we know that n is given as A into B, that is A value we have it as 3 and B value we have it as 11, right? So 11 into 3 is 33. We already got the value of n. After getting the value of n, we select x is equal to 3. X is the public key that we are going to select it as a 3, which is a relatively prime to A minus 1 and B minus 1, which is equal to 20. So when we find the value of A minus 1 is 2, B minus 1 is 10, 10 into 2 is 20. So for number 20, which number is relatively prime? There are a lot of numbers that exist, but right now in this example we have chosen the x value as 3. So then xy mod A minus 1 B minus 1, that is x value is 3, y we don't know, mod 20 is equal to 1, we get the private key as a 7. So we have the public key as 3, 33, private key as 7, 33. So using this public key we encrypt the message. So here we have the message as 9. This is the public key mod 33. We got the ciphertext as 3. So when we decrypt the ciphertext, we get back the original message as 9. This is how the RSA algorithm works. So here we have a question: explain RSA algorithm along with an example. And if you want to get the detailed explanation of this algorithm along with a lot of examples, then please visit this particular website. Thank you.